Alright, so today we're going to look at logarithmic functions. So in order to look at a logarithmic function, we're going to start off with an exponential function, specifically y equals 2 to the x. So what I did was I picked a base for my parent, I chose 2, and I made a table plugging in these x values in for x and getting these y values out. And then I went ahead and graphed it, and here's my horizontal asymptote, which I'll put right down here. My horizontal asymptote, y equals 0. So I wanted to start off with an exponential function because a logarithmic function is the inverse of an exponential function. So inverse of an exponential function. So if you'll recall, to find an inverse of a function, we do what with the x and the y values? That's correct. We would switch those around. So my x values would become my y, and my y values would become my x. So I'm going to go ahead and switch these around. So now I want you to remember that when we translate an exponential function, this is the point that we translate from the parent. This point right here. Now notice that on a logarithmic function, that point changes to 1, 0. So on a logarithmic function, we translate this point. So let's go ahead and graph this point. This is the inverse point. So 0, 1 becomes 1, 0. So let's plot the rest of these. So at a half, we go down 1. At a fourth, we go down 2. 2, 1, 4, 2. So drawing our graph of our logarithmic function. Looks like that. Didn't do a very good job hitting all my points, but there we go. Now, some things to keep in mind. With an exponential function, we had a horizontal asymptote. With a logarithmic function, what do you think we're going to have? That's correct. We're going to have a vertical asymptote. And as the horizontal starts with a y, the vertical asymptote starts with an x. X equals 0. So this is going to be our vertical asymptote for this parent. X equals 0. And since the horizontal asymptote is associated with the k value, what do you think the vertical asymptote is going to be associated with? If you said the h value, good job. Okay, just as a reminder, with inverses, the line of symmetry is what? Y equals x. Good job, Reed. Hope you guys do good with your rocket launch. Wish I was going to Alabama. Sounds like fun. Okay. All right, so let's see, what else? Now, a simple way to write a logarithm equation would be, so this, remember, represents our base. So when you write a log equation, this base, we write log, and the base goes right down here. Okay, so I'd like to now show you how to plug one of these into your calculator for your claw. So we're going to go here, and I'm going to go ahead and clear my document. So the buttons you would press, the log button is going to be the yellow word log. So you're going to have to press Control 10 to the X. Our base in this case is 2, and X goes in this spot as the argument of the log. So the base is a subscript, and then X is on the same line as the log. Then we press Enter. Notice it matches my graph. And we can also go in here to our table, Control T, to get to our table. That's how you enter it into your calculator. One last thing. Parameter changes. So, where are the parameter changes found? We know from an exponential function that the parameters, we have a in the front, then the base, raised to the x minus h in the exponent, and then the k on the end. For a logarithmic function, we're going to have, guess what? A in the front as our vertical stretch or compression, then the word log, then our base, which could be whatever number the base happens to be, and then the argument is where you're going to find x, so that's where you're going to find h. H is always associated with x because it's horizontal, and then k on the end. All right, now let's go ahead and write down a few pieces of information here. Let's start off with the x-intercept, which is 1, 0. The y-intercept for this parent doesn't cross the y-axis, so there is not a y-intercept for this one. We already have the equation of the asymptote down here. It's vertical. Domain and range. Domain is going to start pretty close to 0, but not including 0 on the left, and it's going to go to infinity on the right. And then the range is going down infinitely, and it's going up infinitely. Okay, so I hope you guys are having a good night. We're going to write domain and range, intercepts, and graphing logarithms in class on Thursday and Friday.